Okay, thank you. Thank you very much for the invitation. I'm even more delighted to have the chance to be here and discuss with you this interesting subject with so many interesting people. So, well, what I'm going to present, perhaps if the slides could come up. What I'm going to present is just some evidence on some research that we have been doing on robots in Europe on several projects. As we all know, in the last few years, there have been a very intense debate on the future of work. This was a debate that was probably fueled or at least sparkled by the employment effects of the big recession a few years ago. But it was also driven by some impressive advances of artificial intelligence in recent years and a general feeling of acceleration in the rate of technical change in the digital economy that we seem to all share. Now, a recurrent image, as you know, in this debate is one of robots taking our jobs, almost stealing our jobs. I was very shocked to see that one Eurobarometer asked explicitly whether people agreed that robots are stealing our jobs, and 3/4 of people in Europe apparently believe that, which is a very, very strong argument. Now, the narrative here would be that the incorporation of digital and artificial intelligence capabilities on robots, on robotic technologies, would imply a sudden and significant expansion of the capabilities of replacing human labor in many different types of tasks that previous robotic technologies couldn't do. So this would be the kind of narrative there. Now, for some people, this may lead to mass unemployment even. To other people, at least, there are significant concerns in terms of potential distributional effects, in terms of some types of workers being more likely to displace than others, and that creating issues of inequality, etc. So here we are. Yes, thanks. Now, until recently, there was no data on the use by robots, on the use of robots by companies that would allow to test this sort of employment effects empirically. But in the last few years, the International Federation of Robotics, which is essentially a global association of robot producers, has provided data on robot deployment by country and industry that goes back to the early 90s. So that means that there is already a data set, which is real data. This is robot deployment. This is data produced by the producers themselves, by the people that install the robots, for a couple of decades. This data can be linked to employment data and other data in order to try to test these alleged employment effects. And indeed, there has been many papers published in the last few years that have made this kind of analysis, and in general, they have tended to follow that kind of line of argumentation that I was mentioning before. So they tended to find negative employment effects, significant negative employment effects. So for instance, a very quoted paper found that for the US, each robot would replace more or less 6 workers, and a paper following a similar methodology for the EU found something like 3-4 workers replaced by robots, which sounds very troubling. Now, in the employment team of the European Commission's Joint Research Center, where I work, we were requested to enter into these debates and look at this kind of data and try to identify the impact of robots on employment in Europe in the last recent years. So we acquired this IFR database and we started looking at it. And out of these, there are a number of papers coming. We already published a couple of them. The second one was published just yesterday, so you can look at it if you want. I can send you the link on robot and employment. And there are 2 or 3 more coming in the next few weeks, probably, or months. So what I would like to do is to just summarize some relatively basic, simple facts from these papers. And you can go to the full papers for more details, or we can discuss later if you want. But just to give you an idea of some simple facts that we found that contradicted in a very stark way this kind of narrative that I was mentioning before. So the first thing that we did with this data is to try to understand it better. So basically what we try to understand is what kind of robots are we actually talking about? What do these sorts of robots that are in the IFR data, what do they do? And how they are distributed across countries. So it's easy. I mean, you can actually see, pictures are very informative for this kind of thing. These are pictures that they are taken from the IFR latest report itself, and it just shows the kind of robots, the categories that they use for their analysis. And immediately, you can see that these robots, which are indeed technically impressive, they are very far from the kind of anthropomorphic, all-purpose technology displayed normally in the media to illustrate articles on this subject. In most cases, what they resemble is at most human arms rather than human beings in any way. And although they can normally operate in all directions, in 3 directions, and this is indeed part of the definition of industrial robots that they use, they generally remain within well predefined and limited spaces. And you can get an idea by looking at the pictures. And what they perform is essentially physical tasks that involve moving and precisely manipulating objects. Okay, so this is very specifically what these robots are. In most cases, these robots, and this may come as surprising, but the robots that are actually used in European industry, in the vast majority of cases, they use little or no artificial intelligence at all. And although they can normally be reprogrammed, and this is the main advance in the last couple of decades, that they have been added reprogramming capabilities, which increases indeed a little bit the flexibility of these robots. So they can be reprogrammed to change the specific tasks they do. In the vast majority of cases, they remain physically constrained to perform a very particular application. Okay, and this is, again, it may sound obvious, but this is very important, and I think it's very important for the debate, as we will see later, as I will argue later. So, and you can get, just to follow on the same kind of argument, just to see what do these robots actually do, what you can see in this figure is that actually the vast majority of cases of robots, this is for the year 2016, and this is data on robot applications in Europe. These are the robots installed in Europe. What you can see is that nearly more than half of them, 55% of them, what they do is handling operations and machine tending, and this is basically moving things from one place to the other. I mean, that's what they do, the biggest category of robot application. The second is wielding and soldering, which is essentially about putting together 2 types of material by heating it or putting some material in between. And this is 22%. And the third, which is already tiny compared to the other applications, is assembling and disassembling. Okay, so this, just looking at the robots themselves. Now, why do I think this is very important, even though it's very simple? Because this very simple inspection of the kinds of robots included in the IFR database, it already delimits quite radically the kind of impact we may expect of these sorts of robots on employment. And therefore, it kind of invites some skepticism about the overexcitement that has been in recent years, in some cases, with this kind of data. What kinds of tasks may these robots perform? Basically, they are physical tasks of a relatively routine nature, typically involving strength and dexterity. And as I was saying before, the main advance in recent years has been the addition of algorithmic control and digital sensors, which can increase the flexibility of these robots. But this is still a marginal rather than a radical improvement. And in fact, and this is an important point to bear in mind, previous waves of automation, and not only automation, but just industrial restructuring, industrial reorganization, you know, the good old division of labor of Adam Smith has for not even decades, but even centuries, have already increased enormously the productivity of these type of sectors and this kind of economic activities. And therefore, the amount of labor that is still spent in doing this sort of physical, routine, strength and dexterity tasks is very small. We have another project that we have been doing in recent years in the JRC, in which we were trying to measure labor input by different types of tasks in Europe. And what we found is that even within manufacturing, this sort of task input is already quite small. So again, what this means is that the actual potential of these robots to replace labor is not very big, because you're talking about labor that is already not that significant in European employment. So this is the first point. A second point that we found in terms of looking simply at the data is just by looking at the distribution of robots in Europe by sector and country. And this reinforces the previous skepticism. As you can see in the figure here, more than around 50%, it's around 50% of all workers, of all robots in Europe in 2016 were installed into just one single sector, which is car manufacturing. one specific subsector within manufacturing, which is car manufacturing. Then there is around, the second biggest one is rubber and plastic, and the third metal products. If you put these three sectors, subsectors within manufacturing together, you already have more than 2/3 of all industrial robots installed in Europe. Okay, so this is the second point. Not only robots do very, very specific types of labor, can do very, very specific and narrow types of labor input under very specific conditions, but actually the robots that are installed are only installed to a large extent in very few specific subsectors within manufacturing. Now, in order to get a better grasp of this, how striking this concentration is, it's better to calculate robots in terms of, as a measure of robot density, okay? So we can calculate robots as relative to thousands of workers in the same industry. And there, what you get, and it's not shown here, is that in the first sector shown there, so in car manufacturing, you have around 60 robots per 1,000 workers, okay? Then plastic, which is the second, is already 30 robots per 1,000 workers. And then the third one, which is metal, it's already 10 robots per 1,000 workers. Now, in most of the other sectors within manufacturing, subsectors within manufacturing, even within manufacturing, the density of robots per 1,000 workers is very, very close to zero. So there are essentially no robots in most of the other manufacturing subsectors, okay? So what does this mean, again, in terms of potential implications for employment? Well, what this means is that to a large extent, these kind of robots, the kinds of robots that are included in the IFR database, they are basically specialized technologies to a large extent. They are technologies that are used only in some very specific subsectors within manufacturing, which are, incidentally, the sectors that have had already a very long tradition of automation, work reorganization, and use of robotic technologies, even well before the last 20 years, which is the period that we have covered in the analysis, okay? So again, what this suggests is this kind of skepticism in which what it suggests that what we are seeing with the most recent wave of industrial robots is just a continuation of a very long-term trend that goes very far in European manufacturing, and that there has been no actual disruption or discontinuity, as you sometimes get the feeling in the literature. If you see here, it's also interesting to note, it also shows a breakdown by country, and you can, it's kind of quite striking that you see that the two, the concentration by sector and the concentration by country actually compound, and you get this absolutely striking figure that 27% of all robots in Europe are installed in German car manufacturing, which accounts for less than 1% of overall EU employment as such. Okay, so this is just to give you an idea of the kind of concentration we are talking about. So the point then is, how could these robots, these kind of robots, have any significant impact in terms of employment in Europe? They are extremely concentrated in a few sectors and countries that account for a very small proportion of overall employment already. And what they can actually do suggests continuity. So as I was saying before, it's just a marginal improvement over previous technologies in terms of the type of task input they may replace. Now, a possible criticism to this kind of arguments is that it's actually very narrow, because we are only talking about robots within manufacturing. This is the data covered in the IFR. So maybe some outside of manufacturing, there are robots that are doing something very special, and there is something disruptive going on. Well, again, we have to disagree with that. If you go outside manufacturing, these are the kinds of robots that actually exist and that have actual, real, demonstrable, measurable economic use. If you go outside manufacturing, you get extremely little. There is very, very little use of robots in services yet, and when they are used, we do know a few examples, and there may be something that may be coming in the future, but so far they're not simply used to an extent large enough as to even have any significant impact. And in that case, you know, and this is the point here, that this is something that eventually may change, and definitely, if at some point we can find, and maybe with the addition of artificial intelligence, machine learning capabilities, I don't know, if these capabilities may be added to robots so that they can actually start performing some types of tasks which go beyond these physical strength and dexterity kind of tasks and involve more, for instance, social interaction, problem solving, which is the bulk of task input in Europe nowadays, as you all know, then maybe they would have a disruptive impact. But it's just something that is so far not happened. In any case, we did go ahead and try to estimate the relationship between robot stocks and employment, and this is, as I was saying, you can look at the paper more in detail. It was published just yesterday. But also in this case, just to make the final point, what we found was surprisingly at odds with the general narrative. As I was saying before, we were already expecting a tiny effect because of what we were saying. Now, what we found, if you look at the correlation between robot adoption and employment in European industries in the last couple of decades, what you tend to find is actually a positive rather than a negative relationship. Okay, it's a small one, and in some periods it's not so clear, but in general, if you find something, it tends to be positive rather than negative. Basically, what we found is that in the context of this kind of long-term trend of decline in manufacturing, which continues, which keeps on going on, what we found is that the sectors, the national industries, and German car manufacturing is a very good example, the national industries that installed more robots tend to also be more resilient in terms of employment trends. Okay, so that's why if there was any relationship, it tended to be more a positive rather than negative relationship. So, in conclusion, just to finish with making the point that I've been making throughout the speech, we believe that we're talking about an incremental rather than a disruptive effect of robots in the last 2 decades, certainly in terms of employment. It's more a continuation of long-term automation trends than any discontinuity. And just an image, a kind of metaphor that we find useful to make this sort of point, you know, because we are talking in many cases about industries that are already relatively mature in terms of automation, when the last 2 decades, with the period that we are studying started. You know, these sorts of robots were more likely to actually replace other robots, so previous less sophisticated robots, than actually workers. So that's my speech. Thanks a lot.